All right, Allie, here's the 10-7 stuff. I think we're starting with question 4, the first one you asked for. Okay, find the area of the shaded sector of the circle. Okay, sector of a circle just means a slice of the circle. So this yellow thing here is a sector. Okay, we're going to find that area a lot like we found arc length. Basically, with arc length, we took a fraction of the circle's circumference. For area of a sector, we're going to take a fraction of the circle's area. Okay, so my formula for this is going to be very similar to what we just did. It's going to be the measure of the arc divided by 360. So in other words, the fraction of the circle we're looking at, okay, times, instead of the circumference, the area of the circle, which if you got through 1, 2, and 3, you know is just pi times r squared. Okay, so in this case, we need this arc measure of this yellow part here. Okay, well, if this chunk we don't need is 120, if I go 180 minus 120, that'll give me 60 degrees. Okay, that's the measure of the arc made by the shaded sector. So I'll go 60 over 360, and then times pi times the radius squared. Now I know this 22 is the diameter, okay, since it's centered in the middle here. Okay, the radius will be half of that, the radius will be 11, so I'll go times pi times 11 squared. Okay, and again, this problem's looking for an answer in terms of pi, so I'm going to leave the pi out of it, and in my calculation, I'm just going to go 60 divided by 360 times 11 squared, or times 11 times 11, however you want to do that. And when I do that, I end up with something kind of ugly. All right, so I end up with something kind of ugly. I end up with a 20.16 repeating. MathXL is going to want that as a fraction. So if you do the fraction conversion on your calculator, if you need help with that, let me know. I end up with a 121 over 6. I'll have to type that in as a fraction over pi. I did not mean for this one to be that ugly. Whoops. Okay, but 121 over 6 pi would be what I'd plug in. Okay, so you need the fraction, you need the pi. Okay, it's something you've used before though. Okay, again, if you need help with the fraction thing, you can let me know what calculator you have, and I can help you with that. All right, same idea. Instead of a little slice, you can think of this as a big slice for the yellow, okay, a big sector. I'm going to go the measure of the arc over 360 times the area of the circle times pi r squared once again. Okay, in this case, the measure of my arc is going to be everything besides this 90, so in other words, 270 degrees. If I take 360 minus 90, I get 270, so we'll go 270 over 360, or in other words, 3/4. Okay, times pi times, I'll say this 8 is the radius because it's not centered at the center there, 8 squared. And then once again, what I'll do is I'll go 270 divided by 360 times 8 squared. Again, there we go, and I get a 48. So we'll write that as just 48 pi, nicer number, no fractions. And we can just plug that 48 pi in there. All right, next one we have are some applied problems. We'll read through this. Tim has a backyard pool in the shape of 2 semicircles attached to a square. Each side of the square is 20 feet. Find the area of the pool. Use 3.14 for pi. Okay, so basically we want to find the area of this entire shape here, which is made up of a square with a half circle on both sides. Okay, half a circle plus half a circle makes a whole circle. So basically to do this question, we just have to add the square to the circle. Okay, area of a square, easy. Side lengths are 20, so we'll just say 20 times 20. In other words, 400. Okay, area of the circle, we know circles, again, are a equals pi r squared. So what we'll do is we'll go pi times the radius, which will be half of this 20, a 10 squared. I'm going to calculate that out. And again, it said use 3.14 for pi, so I'm going to say 3.14 times 10 squared. I suppose I could do that in my head, 314. And when I add the two of those together, 400 plus 314 is going to be a 714. Okay, so that'd be what I'd plug in for that. All right, then last one's going to be similar to the inner and outer circle problem we did with the circumference for the last video. Here I want to find the area of this shaded donut shaped. And to do that, there's really three parts. I need to find the area of the entire thing, which is part A. I need to find the area of the smaller circle on the inside, which is part B. And then I just need to subtract the two, and that'll give me part C, the area of the donut shape. Okay, so that'll be A, B, and C. I don't have this working dynamically for you here, but we'll just do the outer first for A. Outer circle, area equals pi times radius squared. So area is going to be equal to pi times half of 105.5. I'm going to do that on my calculator. I'm a math teacher, I should be able to do that without it, but we'll say it's 52.75. And that's squared. All right, multiply that out. And I end up with, whoa, an 8741.677, so we'll say 0.68. I'm doing 2 decimal places because this said to round to 2 decimal places. There's my part A. Okay, B, we want the area of that inner circle, so I'm going to need to figure out its radius. All right, it says that, okay, the diameter of this whole thing is that 105.5, which you just used. Okay, inches, that includes a 2-inch wide painted circle. So basically, if I take this 52.75 and subtract 2 from it, I get a 50.75. That's going to be my radius for the inner circle. And again, I know that because this distance right here, they just said is 2. So the entire way out to the end would be the 52.75. If I take 2 away, I get the 50.75. Okay, so this is the inner part. That's going to be, again, area equals pi times radius squared. So in other words, area is equal to pi times the 50.75 squared. And that gives me an 8091.37, rounding to 2 decimal places. Okay, that'll be what you plug in for part B. All right, then you need a different color here. We'll go green. C, use parts A and B to find the area of the painted ring. So in other words, the area of the blue part. Well, that's just going to be the outer minus the inner. So in other words, the 8741.68 minus the 8091.37. And when I do all that, I end up with a 650.31. That'll be what I plug in for part C. Okay, hopefully that helps. If you still need some help with something, let me know. We can work on specific ones if you need them. Okay, the ones you have pulled up on your screen.